Hello, everybody. Thank you for coming out. I guess I'm going to be starting now. My name is Andrew Sink, and I'm going to do a quick demonstration of 3D printers and 3D printer technology. And we're going to cover some basics about the operation, the use of them, how much it costs to build them, how to build them, things like that. And we're also going to have a little Q&A session and a demonstration. So everybody at the end is welcome to come up and ask questions and poke and touch, things like that. Okay, so before I get started, I just want to thank Jesse Vance for hosting this in the lecture compound. So, round of applause for Jesse. Thank you, Jesse. Okay, so introduction to 3D printing. Next slide, please. I didn't bring a clicker with me. Okay, so just a quick bit of background. 3D printing is an example of an additive manufacturing process. And what this means is basically, instead of a subtractive process like whittling or scrimshaw or things where you're removing material from a base object, you're actually creating something in layers. And the idea is basically you can create something using a minimum of waste. You can create just the object itself. And that's what these are doing. This floor would say. And it's actually printing the object in layers. The technology first appeared in the 1980s. In 1984, Chuck Hull actually invented the first stereolithography printer. And we're going to cover what that is and different types in a second. But why this is relevant to everybody here is in 2009, there was a home printing revolution. And that's when people first started building kits and started asking the question, well, if they can build one, why can't we build one? Can we make one ourselves? And the answer is yes. And this is a kit printer. This is a printer that was bought as a fully functioning assembled unit. And this is a kit printer that is currently in progress that is actually the child of these two printers. All parts were made from these. So, all right, next slide, please. Okay. All right, so just to kind of go back a little bit, in 2009, the MakerBot Cupcake was released, and that's this right here. It's called the Cupcake CNC. And basically what this printer was, it was an open source project. All of the plans, all of the software, all the hardware was released online. So anybody could download the schematics and modify it in any way they saw fit. So when this printer first came out, it was pretty bare bones. It didn't have a lot of features. It could make an object and that was about it. And then somebody came up with the idea of making a conveyor belt for the actual print bed. So you would build something and it would be built from the ground up. The conveyor belt would spin, dump the part into a box, and start making another. And everyone loved that idea so much that every one of those that came afterwards had that feature on it. So that's kind of an example of this open source collective. And everybody was free to make these modifications, but more importantly, to put the modifications online so other people could see them as well. So there's 3 main types of 3D printers. We're only going to be covering one today, and that's all 3 of these in front of you and everything you see here. And that's the FDM, Fused Deposition Modeling. SLS, Selective Laser Sintering, and that's what you're going to see a lot of metal made out of. And what they do is they actually take a metal dust, and you put a layer of it down, and you selectively shoot it with a laser. Then you blow the old dust off, and you put another layer on and shoot that with a laser too, and eventually you have this formed metal part. Cool, expensive, probably not going to see those in home use for a little while. SLA is another type of printer that's stereolithography, and that uses a ultraviolet light to cure a resin. How many people here are familiar with Form 1, the Kickstarter project? We've got one. Awesome. Form 1 was a printer that came out, and basically it took a big reservoir of liquid, and you would create something by shooting it with a ultraviolet light. Really cool technology, really cool stuff, but they ran into a lot of patent disputes, and it's been tied up for a while. All right, next slide. So how does a 3D printer work? Basically, the way that it works is you take this material here. This is PLA, it stands for polylactic acid, and it is a corn-based, it's a renewable material that is machined to a very exacting dimension, so 1.75 millimeters. And this is actually fed through what's called a hot end. So you have a bunch of gears that actually push this down through this guy. And what this does is it's controlled by a CNC-type apparatus that moves it to create an object. So what you do is you have the computer basically tell it, okay, draw a box, move up a fraction of a millimeter, draw another box, and then continue all your way up until you have an actual finished product. So you can see here on both of these printers, they have these hot ends, and they're actually producing objects by moving around. Next slide. This looked way better on my laptop when I was looking at it this morning. So this is an example of how you can make an object that has, these are all solid lines, but they're forming a curve. And you do this by creating thin layers that are very shallowly stepped. So it creates this sort of art. And this is where you can see it here, how it's actually made. And there's a YouTube video here that will watch something being made as a time lapse. So you can get a better idea of how it looks when it's actually operating. Is anybody here familiar with Adventure Time, the cartoon? This is a Princess Bubblegum crown. So that's an object being made. That's obviously pretty sped up. That object right there probably takes a little bit closer to 30 or 40 minutes to actually produce. The printer runs fairly slow. These ones run about 15 to 30 millimeters a second. Not very fast. Next slide. This is a large picture of one of these. And so basically, this is the hot end here. This is the object that's actually being constructed. The filament is being fed up top through this extruder. This is a series of gears that actually push it down through this tube. And this is a heating block. So this material is being heated up to about like 180 to 200 degrees Celsius. Once it gets here, it comes out through a very, very fine nozzle, usually between 0.4 and 0.1 millimeters. So it comes out really, really thin. And you can see that when everybody comes up at the end and takes a look at these, you'll notice that from a distance it looks like this is one solid object. But if you get close, you can actually see each individual layer that it's composed of. Next slide. So a big part of this with 3D printers is there's a really important concept of open source versus closed source. And that's something that, especially for home 3D printing, it's really important to kind of look at. This is an open source printer. All of the plans for it, all the schematics, all the software are freely available. Anybody can download it, anybody can improve on it, anybody can modify it. This is a closed source printer. When you purchase this, it's just like purchasing a copy of Adobe Photoshop. It's a piece of software that once you own it, you really can't make any modifications to it. It kind of runs as is. Open source, some of the pros of open source, information is freely available to modify, to customize, to share. Generally released under a non-commercial license, which is good because it lets you do whatever you want to it, but it's also, if you try and sell it, you're actually prohibited. So it keeps people, keeps things from getting too competitive with making advances. Closed source, there's really no customization that you can do to it. But it is also, these are generally released with like end user license agreements. So whenever you buy a new piece of software, you scroll through that like 300-page block of text. That's basically telling you that you can only use it the way that the manufacturer intended you to. Next slide. So we're going to talk about a little bit of documentation. And this is hopefully where it gets a little less dry and a little bit more fun. Can we do the first link? So we're just going to scroll through here real fast, and this is just something that I kind of want to show. This is what got me into 3D printing. This is back in 2012. I had really no experience with 3D printers. I had heard about them. I kind of wanted to get involved and wanted to start playing with them and like learning more about them. And so for a project, I thought, oh, well, I'll just print out like a bust of my face. That's something people do, right? So I thought, okay, well, how should I go about this? So I had a friend of mine, if you scroll down a little bit, you'll see a friend of mine took about 180 of the least flattering pictures that you will ever see of a person, completely all the way around, and we did a complete circle of myself. We wound up with a 3D model. And this is actually a representation of me in three-dimensional space. And you'll notice there's a major hole in the top of my head because we didn't think to take any pictures up top. So we were going through these, and we printed out, or we captured all the images, we fixed it up. I want to scroll down a little bit. We fixed it up to fix the hole on the top of my head, and under my chin, and all that jazz. And keep going. And yeah, so we eventually got this 3D model, and this was an STL file, which can be read by any printer, any CNC router, anything like that. And that was kind of like the end deliverable. So once we had this, we were able to actually cut it up and then print it out. The first thing that I did when I got this was I went to the lab, the school I was going to, State College of Florida, had just bought 2 really big 3D printers, and I was the first person to use them. So I was like, I gotta make this bust myself. And I made 2 of them. They're both about the size of bowling pins. And the lab director freaked out when he saw it because I made it completely solid. And it turns out the material is extremely expensive. And I made 2 of them. So yeah, so it was a cool project, but more importantly, it was cool because I actually didn't pay any money to do any of this. This was all done using free software, and I documented the entire process. So really anybody could go buy, anybody who has an iPhone really can get the software, model it on a computer, render it, and then have a 3D model. And the cool part of the model is once you have it, it's yours. You can print it on any printer. Any of these printers can handle making one of these. You can send it. I have one that I actually made of ceramic that I had fired in a kiln from Shapeways. And all right, so go back. Let's try another one too. So this is part of the documentation I was talking about. And with open source, it's kind of, there's definitely a collective groupthink mentality with it, where when you make advancements or when you build things, you really want to make sure that you document your work. And you're making sure that you're taking pictures and trying to let everybody know what you're doing. This is what this printer looked like when I bought it. It comes as a complete kit, literally just a flat box that you get in the mail. And all of the individual components are laid out and labeled and everything, so all you really have to do is put it together. It took me about 2 days to build, and it's taken about 1.5 years to get it to where I even kind of feel comfortable letting it run overnight. But yeah, so if you go down, you can kind of see as I was going through it, I took pictures of it and just made sure that I was kind of retracing my steps and understanding how everything worked. And it was a really great way to get into 3D printers. And that's definitely the route that I would recommend anybody to do. If you're going to buy a 3D printer, building it's a great way to understand how it works. Lets you really get inside it and figure out how it works, how it runs, all the important stuff. So yeah, so this was a really in-depth tutorial. You can find it on the website, syntax.com is where I put all of my projects and things that I've built. And there's a lot of documentation on projects like this. But so this one's a little bit more in-depth and was talking about some of the software I use and things like that. If you go back, the other printer that I got, literally, this one comes fully assembled. This comes in a big shipping crate, and you unbox it, and you plug it in, and it worked immediately. Which felt great after spending 1 year working on this one. So the documentation on this one was way more straightforward. This was something that was, it literally just came out of the box. And this is my cat, Virginia. I have to throw this in here real fast. Last time I came to the venture compound, actually, I found this cat wandering around outside. And I took it home. And now I have a stray venture compound cat at home. But yeah, so this is what this printer comes with. It comes with gloves because you have to use a blade to remove the support material. And anybody can see my hand. It looks like a butcher block after the first month I had this thing. So they send the gloves and some basic material. You can see this thing right here. But this one was a lot more straightforward. I just unboxed it and then turned it on and hit start, and it ran immediately. Which is kind of going back to the open source, closed source issue. Less customization, definitely less. You can't control it nearly as well. And everybody's welcome to come and look at the software too that you use to control these two printers. You have full control over this one. Every motor, every trim pod, everything's fully adjustable. You have literally no control over this one. You only have a press play button. But also it works every time. So that was an hour after I unboxed it. That came out, and after spending a year working on this one, just thrilled to see that. All right, I think there's one more link in there that I wanted to kind of show. And this is an open source project. So this is an example, like I was talking about, documenting work and showing things off. This is part of a prosthetic or a robotic arm. They're making a prosthetic version right now. And it's an open source project. A guy named Gail Langevin is working on it. It's called the InMove. And basically, the idea is that it's a fully robotic arm that has the same degrees of freedom as a human arm. You have a hand, and then you have the arm here. And it has all of the same movements as a standard arm. And it's an open source project, so people are free to come up with improvements. So after the first generation came out, people started saying, let's make a wrist that spins. So the next generation, all of them had wrists that spun, and things like that. But there wasn't really any documentation on the finger, which is this right here. It's a small drive mechanism that you can actually see the servo controlling the finger, so you can see how it actually operates. So this is an example of just a write-up on how to do this. All of the source code's available online, all of the parts, you can download everything. and there's a full bill of materials, so you know what you need to actually make it work. So that's an example of like open source documentation. And once you start getting into this and like learning a little bit more about 3D printers, you start to see a lot more of this hobbyist grade documentation pop up. And people who are really talking about like how can we improve this, how can we make it better. Oh, am I sweating? I feel like I'm sweating. I saw the towel and I thought that was the indication. So yeah, cool. So I think there's one more slide here, and then we can be done with the PowerPoint, and then we can start doing the fun stuff, which is like coming up and touching it and playing with it and talking about it a little bit more hands-on. This is the cost, like how much everything costs. 3D printers is a little bit, initially it can be a little bit like disconcerting to think about like how, like when you see the prices of some of the high-end kits, they generally don't start at under $3,000. So a lot of people are put off by that because it's like, that's too much money, I don't know if I'm going to use it very much. But when you actually get down to it, for under $1,000, you can totally do this. This one right here was $399, I think I said what the kit was. That's how much it cost by itself. In upgrades, I've definitely spent at least $450. Pretty much like every metal part, this whole front end, like everything's different. Everything had to be changed. And the more you learn about it, the more you start to see it the same way that somebody who's really big into cars would look at their car and say, oh, well, this needs a new part. You start to look at this and you say, well, I want this to go up higher. I need a taller rod. Or I need this to move faster. I need better belts. So you start getting into upgrading. It gets really expensive. The material is also a little bit more expensive as well. PLA is that core-based material. Cool, totally compostable, renewable energy, or renewable material. Very cool, but also it absorbs moisture, so it goes bad very fast. This right here is a spool that no longer works because it was out for too long. The material actually swells, and when it swells, it won't fit through the extruder anymore. So you have a very short window to use it unless you keep it stored well. Whereas this one uses like ABS plastic, which is what Legos are made out of, and does not go bad. This one cost $829, and I put 23 cents into upgrading it. And I printed one new part for the back, only because I thought, oh, that could look better maybe. So I did that, and that was it. And it runs perfect every time. The material's also a little bit cheaper too. Generally speaking, there's a couple different manufacturers that make the stuff. With this one, the sweet spot is like usually around like 30 bucks or so each a kilogram. And if you're wondering how much a kilogram costs, or how much it can make, all of these green octopuses here were made from the same spool. It can make about 70 of these things. So you definitely, and for 30 bucks, it's definitely, you get more bang for the buck for that one. All right, I think that's just about, that's it for this. Thanks to Jesse and Adventure Compound for hosting this event. So I'm also kind of, I'm not much of like a planned speaker. I don't like using this kind of stuff. Definitely more a fan of question and answer. So please ask questions. I'd love to talk to some people with their hands raised already. Hello.
Hey, which one was the one that you were using weed whacker twine for?
Weed whacker string. Yes, you can absolutely use weed whacker string too, as it turns out. You can just feed it right through the extruder nozzle because it is the same diameter. Do I recommend it? Absolutely not. But you can totally do it if you feel adventurous. Yeah, you can use, there's all kinds of materials too. Some people started inventing, there's brick and wood, and there's actually a carbon fiber that just started, and it all ties back to that open source mentality. People started playing with different materials. People started saying, well, what if we use, my favorite is the wood. Somebody was like, well, what if we take a wood powder and put a very fine, like very small amount of glue in it, and then extrude it so it's this diameter. So as the printer prints it, it actually creates a layer of wood, and the glue is burned off in the process. So when you're done, you can actually make like little tiny wooden chairs from a 3D printer, which is really weird to look at, but really cool to see. And then someone took that same process and applied it to bricks. So you can actually print little cinder blocks too. So you can make little tiny little miniature houses, things like that. And somebody actually just came out with an idea for putting threads of carbon fiber through it too. And carbon fiber is extremely strong, and this stuff doesn't really have super high tensile strength. You can snap it pretty easy. So that the carbon fiber would be cool for moving parts, bearings, things like that have stress applied to them.
Is there anything about taking an AutoCAD 3D model into the software or some kind of conversion?
So AutoCAD, most programs will export in this file that these printers use is called the STL file for stereolithography, and it's the same file that you'll find in a lot of like CNC routers. They're generally universal. AutoCAD can export it natively, so can SolidWorks. Other programs like open source ones like Blender and Tinkercad, you can install plugins to do it. If you know how to use SolidWorks, or if you know how to use, if you can build small objects in AutoCAD, you can definitely export it into a file that will run with these printers. And you can apply that towards, building something and making a prototype and printing it out like an hour later.
So when you're exporting these files, because I know, I remember you told me once how anything that's inside, you have to build the whole lattice structure so it doesn't.
Oh yeah. Okay. Cool. Yeah. So support material.
In AutoCAD, does that automatically put it in, or is that something that the printing software that comes with these
The
things
printing software is actually, it's a user, that's actually customizable. So if you look at one of these things, they're actually, plus myself, if you look on the inside of them, there's a very fine lattice work. You can kind of see how it looks like a honeycomb structure. So the denser that honeycomb is, the more material it takes to actually build the object. So it's more expensive, but it's also stiffer. So you can use it for objects that are, if you're using something that's like a doorstop, you want to print it completely solid, so it would be really tough. But if you're just printing something like these, you can make it a little bit more hollow. Sure. So that one right there has a very fine lattice work, so that's going to be a denser object. So you can kind of see how it's like a honeycomb structure.
Yeah.
Whereas this one here is going to be, this one's kind of looser. You can see that the gap between the spacing is a lot bigger. So when it comes to how much material you use, that one used a lot less material, so it's a lot cheaper to make, but also, you probably wouldn't want to stand on that, whereas you could probably stand on, well, this guy's got a big nose, so I would stand on him. But it's going to be a little bit stiffer, and that would be better for, and also partially too, for if you're making parts that weight is important, printing it solid is definitely the way to go. Everything that prints out here too, as it prints, when the plastic cools, it shrinks. As the plastic is cooling, it actually shrinks. So what will happen is it will start to kind of fold in like this. So these printers, the bed is actually heated. So as the part is being made, it's kind of like glued down. Once the part is finished, it'll slowly return to room temperature to keep it from warping on the sides. So when you print it solid, you have more material. It's going to cool, it's going to shrink more dramatically. If you can print it hollow, it tends to stay a little flatter, and it's a little bit nicer when you use it.
You just talked about that lattice inside to help keep it together and keep it pretty stable. What if you wanted to do like a little model of a house, some kind of building?
You could absolutely make something like that, and then you
interior walls and window openings and things.
Yeah, so there's something called support material. So as you can imagine, like if you're making a shape like this, you're just making like an upside down U, there's nothing under that top part. So the printer makes something called support material. So it'll build this kind of like little jagged piece that supports that top part. And when you're done with it, you actually knock it out. So if you were to make a house, if you were to make like an upside down container with no bottom, when you printed it out, it would be filled with this like support material that when you flip it over, you can just pull it out, and then you have the hollow inside of the house with little windows in it too.
The software is doing that automatically.
Software is generated, or the support material is generated by the software, depending on what kind of software you use. The closed source, like this right here, the support material this produces is amazing because it literally just peels off. This is actually something that printed earlier. This is an example. Like this, you can kind of see how this one's sitting on like a raft. And this is what it looks like when it comes out of the printer. But then this bottom part, you can just peel off. And then you actually have the object under it. So that's how it adheres it to the bed. Otherwise, these parts right here will curl up. You'll have an octopus that's kind of doing this. And this actually helps it stay like locked down. Cool because it keeps it down. Kind of a bummer because it's wasteful. Unless you have something to reclaim this is now material you have to kind of say goodbye to. Which is always a shame when it comes to this kind of stuff because you want to try and reuse as much as you can.
How can you reuse it then?
There's something called a fill extruder. There's a machine that actually has, it looks like a big tub, and you can take plastic things that you don't want and just throw it in, and it grinds it up, feeds it through, and there's a large heating apparatus that actually produces this material right back onto a spool. So it's cool if you're trying to reclaim the material because you can just take everything that came out like looking kind of funny and just throw it in there and reuse it.
And is there a limit?
Yeah. Sure. Mesh Mixer's great, yeah. all right, so yeah, just bring everybody up to speed, and I'll definitely answer that. When you print an object, it has to be manifold. Manifold means watertight. If the object has, like, when you saw that, like, print of, like, my face with a big hole in the top of the head, when the printer sees that, it has no idea what to do. It can't handle an object that's not watertight. You have to actually seal everything in. So you have to kind of cover it. If it's not manifold, the printer will return an error and say, can't touch this. So you want to make it manifold. Mesh Mixer is great. NetFab is fantastic, too. NetFABB, and that's a program that what it does is it goes through the model and it actually checks to see if there's any holes, and it doesn't examine it like a piece of printer software would. It actually probes for any possible errors, and then it automatically fixes them. So something like this, the material cost of something like this would probably be somewhere between like 20, if it's solid, maybe like close to like 50 cents, maybe $1 or so. It's important to note too, the electricity usage for these are really high because they're basically giant, it's basically like having like a hair straightener just plugged in all the time. The heat element uses quite a bit of electricity, and each motor, the X, Y, Z, and extruder, these are also, these motors use a little bit of juice too. So there's a certain amount of electrical cost, and there's also the support material too. When these come out, these actually look like a cylinder. It's just a complete tube, and you have to actually remove the support material from it. And that also takes time. Yes?
So in doing this little building, you could not have window and door openings in it?
You could have what?
Window and door openings.
No, absolutely. Well, you could, but then they have to have, like, just like a window and door opening. If you were kind of like look at it, it's still three-dimensional. If you were to look at a window, you can kind of see that it's coming out, but it's also going back before it goes outside. So it's still a three-dimensional object. If you were just to have a gap right there, it would return an error for sure. Yes?
So when you were saying you can recycle the material earlier, is there a limit to how many times you can do it? Like,
eventually the PLA, for instance, like I said, the PLA, it starts to absorb moisture pretty quick. And once it starts to absorb moisture, the material itself is kind of compromised and it starts coming out pretty poorly. Honestly, we're at that. This is kind of cool because it's kind of a new technology like the Illustrator and stuff. We haven't really hit that limit yet. Like I don't know how many times you can reclaim it, and hopefully, eventually somebody's going to hopefully document the project of like I'm just going to print the same piece and then throw it right back in the machine and see how many times I can do this. But I mean, we've definitely done two. I think so far with the extruder or with the machine that we have, I think we've done it 3 times now or so. Has been like the number of recyclings. But that's with the ABS material too. It's a little bit more user friendly. Yes?
Is that material you said that goes bad? Like, I forget what you call it.
The PLA material.
Is that more stable once it's made into a thing? Or is it always
oh, sure, yeah. Well, once it's apart. I mean, like this, for instance, like if this started to absorb moisture, you wouldn't notice. Okay. It would maybe swell like a little tiny bit, but it wouldn't really be something you would see. Versus this needs to be a very certain diameter, otherwise the machine won't accept it. If you were to make something that's got if you were to make moving parts, like if you had a small gear assembly, that could potentially absorb moisture. That would be something you might want to consider sealing. And then you would want to try and find some kind of like sealant or something like that. With the ABS, you can use acetone to smooth it out, make it completely flat, get rid of the ridges. Yes and no.
Thank you.
Yeah. Oh, I'm sorry.
Okay, go on.
I'm sorry, I saw 3 people pointing.
Okay. Why can't you use acetone on the formula?
The acetone, it doesn't do anything. This actually requires a compound called methyl something you can only buy from like a chemical supply store. It's apparently extremely hazardous and you don't want to play with it, is everything that I've read about it. If you can put acetone on this, but it's just like putting water on it, nothing really happens. It doesn't change the properties. This material just isn't affected by it. The ABS, you can put acetone on it. Once again, on the website, synchhacks.com, which is where I document everything, I actually built an apparatus that boils acetone and uses acetone vapor to smooth the parts. Much more stable because it gives you a lot more control over how much vapor is coming up as opposed to just like dunking it in a vat, but also a lot more dangerous because you have acetone vapor coming up. So, acetone you can use it on PLA, it just doesn't have any effect. The material it has, or the chemical that has the same effect on PLA is extremely hazardous, and everybody that I've seen who's tried to use it is just going right back to using acetone on the other material. Yeah?
Sorry, how can you do things with multiple color?
So that's another thing. So printers, right now, really the materials you'll generally only find one color on a spool. This is actually made from pellets. They take ABS pellets and feed it into one of those big grinders that puts out this material. if you put in 2 colors of pellets, what's going to happen is if you put in black and white, you're going to get a gray spool. It's not going to come out in like sections. People have experimented with trying to feed in yellow pellets and then throwing in brown ones and just seeing like, you know, if you can see a clear separation. I actually got curious about that once and did something similar where I was feeding in a white piece and then I snipped it and just kind of like manually held a different color and just fed it in as it was going. And I got a piece of, I made a print that was 2 different colors. You can do it. It comes out looking a little bit, there can be a little bit of a gap because the printer is not having material fed through it consistently. So you can have like, so if it's like a solid piece, it'll have a little bit of a hole in it, which creates like huge problems as it starts to build up further. But it's something you can definitely do, and there are companies that are starting to make like, they've started experimenting with like small spools of plastic that are multiple colors. But it takes a little bit of dexterity if you're trying to do it yourself.
Yeah.
Does anybody have any more questions about the printers? Everyone will come up and see them. Oh.
Are you going to have this presentation online?
I've seen the backs of a couple of iPhones. So I think a few people
we're filming it. The Venture Compound will post this online. I'm recording audio, recording video from multiple sources, and this will be online because I got friends all over the place that wish they could be here.
Oh, awesome. Cool. Be sure to watch this later and just, oh my God, I'm stuttering.
You didn't stutter at all.
Yeah, you're fine.
But yeah, so those are the printers. If anybody else has any questions, definitely shoot them now. Or if it's something you want to ask one-on-one, come on up. Take a look at these things. See, these are for everybody, by the way. Everybody is welcome to take one of these home. It is an octopus fridge magnet that you can put on your fridge or put it wherever you would like an octopus, on the hood of your car. Yours.
I got one. So what do you see? So past the novelty of making small things, there is, I mean, we've read about stuff where they use concrete and they make, they can do like curves for, you know, architectural structures and stuff like that. What do you see, like, beyond where we're at now? Where do you see the future of this?
So one of the big fields that I think is really cool is, it's kind of a small one, and it's not really applicable to not applicable to a lot of people, but homemade and hobby-grade prosthetics are a really big deal right now. And that's something that it's a really cool field because right now prosthetics are extremely expensive, they're very difficult to fit, they're very difficult to modify, and there's a lot, the same person who actually made this, this hand, which everybody's welcome to come up with and shake later, that same guy's working on a prosthetic hand that actually has 3 fingers and a thumb that's used for gripping. And the idea being that this would be something you could modify to fit, you know, the injury of the user. And yeah, that's prosthetics really big deal. Prototyping is huge too. I work for an electronics company, and we generally will send out for prototypes for things to be made. But the idea of being able to say like, oh, what if we could make this with, you know, a rounded edge instead of a straight one? And you can actually just go ahead and print it and have that finished product like a few minutes later and test it out and say, yeah, that works, cool. As opposed to having to send it out, wait a few weeks, get it back, put it in, it doesn't fit, you know. So prototyping is a really huge draw too.
One other question: the printing head. Could you talk about again about exactly how that works, where it feeds it? Yes, the extruder.
Yeah. So the extruder is what actually is like, that's kind of like the heart of the printer, I guess you could say. This material here is actually fed down through a tube into an apparatus that has something called a Hobbs bolt, and it's basically a bolt that's got teeth drilled into it. So the material. Let's grab a good chunk here. Exactly the hot glue gun. So this would actually be coming down straight through, and this bolt has little teeth in it. So as the bolt spins, it bites into the material very lightly and pulls it down. So this is actually being fed straight down. And because this is heated up to anywhere between 180 to 260 degrees Celsius, when it hits the bottom, and the heating block here is covered with red tape, just sort of as like a reminder, don't touch this. Once it hits there, it just begins melting. So the material is pushed through and fed down. So it's actually coming out as a very fine strand. And then that strand, what's being drawn, is actually controlled by the printer itself.
Thank you.
Yes?
So you've got the hardware component, software component. When you find ready-made things?
Ready-made?
Like that, the one on the end.
Like the printer?
Yeah, that comes with the software already built in, right?
That comes with the software package, and you can see this one. This software package was actually translated extremely poorly for a different language, and so as a result, it's full of like misspellings and errors. And because it's closed source, there's nothing you can really do about that.
Can you not they had another software from that computer.
Not easily, no. These ones are actually made to actually interface with this software. I've yet to see an open source piece of software. Some people have replaced, there's electronics boards that control all of the motors, and those boards actually interface with the specific software. So I've yet to see somebody, I'm sure there's somebody out there who will eventually. I saw somebody take this printer and actually take the electronic components out of one of these and put it in here just because he was so sick of using the software this came with. But that's part of the open source and closed source. This is closed source, you can't modify it much, but it works very well.
We were talking about, you guys said they made a liver. They
Sure.
made, you could feed skin cells into it, or, I mean, can you go small enough to make like a DNA strand or something like that?
I don't have the answer to that question. As far as medical applications go, I know there's higher end printers that can do things like that. Yeah, like bone implants, that's something you can absolutely do. But not with, you wouldn't make anything metal grade. I wouldn't want anything that comes out of one of these being put in my body. But there's definitely medical grade printers that can do. That's when they use the stereolithography. That's where the ultraviolet light cures the resin. That's a bit more stable components, and that's what you can probably use for something like that. Let me get him, and then I'll get right to you.
If you're not a designer, is there like a database online where you can browse through designs?
Absolutely. Yeah, I don't have a designing bone in my body. I'm terrible at drawing. I'm terrible at like the CAD programs. And, I can use SolidWorks and Tinkercad like a little bit. But there's a website called thingiverse.com, THINGIVERSE. And it's basically just like how clipart is a repository of image files, Thingiverse is a repository of three-dimensional images. And that's where, for instance, like this was actually made by, this was designed by somebody, and then it was modified, and then somebody added a hole to put a magnet into, and then a friend of mine made the legs thinner so it printed better, and it kind of like goes on these iterations, but each one is posted on Thingiverse. And that's kind of like, that's kind of the default one. There's tons of different file sharing sites where you can download these models, but Thingiverse is the largest and has the widest selection. Thingiverse, the website is owned by MakerBot, and is not an open source company, but the actual objects themselves are generally released under non-commercial licenses, or you can release it under whatever you want, but in general, a lot of these will be released under non-commercial licenses, meaning you can build it, you can do whatever you want to, you can modify it, but you can't sell it. Yes?
Okay. Like devil's advocate, what's your opinion on the 3D print capabilities by putting copyright laws and these things that?
Oh, tremendous! I mean, it's brutal. It's like, I mean, I just imagine it like when the first movie executive saw a VCR and just went, oh god, like, like it's huge. Because of course now you can just go, you can make your own Mickey Mouse at home, just skip the whole trip to go get like the tchotchke. Like there's the copyright, the copyright infringement is definitely like, that's a huge issue, and I mean, and this, because this is kind of in its infancy, like we're still getting to the point where it's like you're starting to see these more, like it's becoming kind of not normal, but more common to run into somebody and say like, oh, I have a 3D printer. Oh, I do too. Like I have one that I play with. Like you're starting to see them more and more. Yeah, as far as copyright law goes, like that's a whole terrain that we're sort of approaching right now. Sure, and that, and I mean, of course, that's part of the open source like ethos. It's like, of course, if you build something, of course you want to give it to other people and share it. Like all the plans for this printer, this is a Mendelmax printer, and the plans for this are freely available online. And you can just go ahead and make your own version of it, or upgrade it, or do whatever you want to it. And I mean, of course you want to do that, but companies, if they're making money on something, they're not going to want to say like, oh, here, you can just make your own at home. So. So firearms are a really cool topic, and I think actually you had your hand up first. So let me answer this question, and then okay, so firearms. So this is a really funny one, and I actually I go to USF, and I just did a project on researching the legality of 3D printed firearms, and it's really weird. The ATF actually put out a statement saying like, yes, we're aware that people are building their own firearms, and it's totally legal. You can make your own gun. That's not like, that's totally legal. That's fine to do. And you can absolutely make a 3D printed gun too. And the plans for it were available online for a hot second, and they're still kind of out there if you look. Is it safe to make? Like, no, it's made of plastic. Like, why would you ever want to shoot something made of plastic? Yes, you can download them, and yes, you can make them. and they technically do work. In general, like, you know, you'd be better off with just like a copper pipe and a hammer if you're trying to make something to fire a bullet with. You're going to lose fingers. But as far as legality goes, like, oh my God, have at it. Like, go for it. Like, it's 100% legal. That's always a tricky question to answer, because I don't want to sound like I'm endorsing them, like, oh my God, everyone should have a gun, but like, but yeah, like, as far as 3D printing guns go, like, you can definitely make them. The plans are available online. They're so dangerous. They are just so dangerous. I feel like I've accidentally emphasized that, and that's kind of a good thing.
Hold on.
Hold
on. In the seminal 1993 classic Clint Eastwood film, In the Line of Fire, the John Malkovich character does build a gun out of plastic.
Sure.
So
I don't recall that scene.
Now what?
Well, yeah. So, you know, so like, yeah. I mean, he didn't have a 3D printer, but if he did, he probably would have done the same thing.
Remember that?
Jumping
We
off
have
of
it.
that, isn't
Put it
it
up.
to be legal, it has to have a metal component?
Correct. Yeah. I should probably let me go ahead and let me mention that too. The ATF requires that you have, I think it's 1 ounce of metal in it. So the plans for the gun. So it says off detectors, yeah. I mean, a little bit, anyways. But yeah, but that's the mentality. Is like, well, we'll detect it if there's like a piece of metal in it. So all of the receivers for the gun, or the like under the barrel, there's a small void where you can, and you are supposed to put 1 ounce of metal. So that's that was kind of like the loophole, you know, made it legal to build. But yeah, then you've got a block of metal shooting down at your foot. Like, it's just, yeah, it's legal. It's very dangerous. Some cities, the city of Philadelphia actually outlawed them. And they said the 3D printer gun, the manufacturer of 3D printed firearms was completely illegal within city limits. They're within their rights to do that. Nobody's challenged it yet. I don't really know how it's going to play out. And as far as I don't know, other cities have actually stepped in and taken similar measures.
Just because it's legal doesn't mean it makes sense to do.
Yeah, exactly. You can also like jog on broken glass, but like you definitely shouldn't. Yeah, the gun's a tricky issue, and like I get asked that one a ton, and I'm never sure how to answer it. But yeah, yes.
For those who are into the costume design, like making props for.
Well, cosplay is huge with 3D printers.
Thinking cosplay.
I know you didn't want to say cosplay out loud, so I went ahead and said it for you. Yeah, cosplay is huge. Like I said, so that video I showed earlier was a princess bubblegum crown being made. We also make an ice cream one too, if you like Adventure Time. Cosplay is, oh, we just finished the part. So when this thing finishes the part, it kind of pushes it forward and presents it. So now we have one of these. Was just made. And then to make another one, all you have to do is take the build platform and throw it back on. And then hit restart. And now we are on our way to making another one of these. But yeah, cosplay is huge for prop building. It's really big too because you can. It goes back to that rapid prototyping idea, where if you want to make yourself like a crown or something like that, you can build one, and then if it doesn't fit quite right, you can just go right back in the program, and like 8 seconds later, you've made the adjustment, as opposed to like buying something online and getting it like it doesn't fit. Yes.
Do you find there's like a limitation on size? Like, 'cause I can see that's a kind of a small.
Yeah, absolutely. Yeah. So this is 4.7 inches cubed. Is the maximum build platform. I've never tried making something that big. I've only really made something like probably closer to like 4 inches or so. This one is like 5 by 3. It's kind of like postcard size. Larger printers have bigger build platforms. Then you encounter that curling problem where the material actually kind of curls on the edges because it doesn't cool properly.
Well, I'm just imagining like possibly like a sword or something.
Oh yeah. Oh, we actually the demon sword from Adventure Time 2 is another thing. But you make those components kind of like this.
Okay.
Like this is something that was made on this printer here, and this is you can see 1, 2, 3, 4, and then a face. So this is actually 5 pieces that were later put together.
So you just section it.
Yeah. So if you wanted to make like a sword, you would just create the model and then boom, 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 and print it out in pieces. And then you can use acetone to weld this stuff together, or you can just use like this was like crazy glue or something that I used for this one. I saw a hand over here.
What about electronics? Is that far off? Like making?
Actually, so interestingly enough, you can make homemade circuit boards, but you have to kind of use a little bit of like outside the box thinking. What I've made, my friend made, and I played with, it's a 3D printed circuit board that uses conductive thread for the wiring. So you can rapid prototype boards, and it's basically like a breadboard that you can make like instant customizations to. But more importantly, you can build it onto an object. So if you wanted to make a circuit board inside a box, you would actually make the circuit board the box with the components inside of it already using conductive thread to wire it together.
Well, how long until we can just print an iPhone?
I'm sorry?
How long until we can just print an iPhone?
That's going to be a hot second.
When can I download a car?
When I download a car, yeah. Once again, might be a second. Yeah. That's a magnet. I put I should probably go ahead and clarify. That was my bad. Sorry. The magnet, yeah. So when these things print out, they're actually hollow on the inside. Well, there's a little hollow void here, and then we just take a little bit of glue, drop it in there, and just put the magnet in. Nothing to do with production. That's not put in there by the printer. Oh, cool. Oh, make 3D printers? I'm not familiar with them, but I'd love to check them out. Wait, is there anybody from this company here right now? Now I'm sketched out. Free Fab? I'll check it out for sure. That's super cool. There's not. I haven't seen a whole lot of manufacturers. There's definitely none in Sarasota, as far as I know. But it'd be really cool to meet some people who are actually making them. A lot of people manufacture these, like the open source designs, because some of them are released under commercial licenses. So you're allowed to sell this when you're finished with it. Some of them are. Oh, the Lullsbot. Lullsbot's a Mendelmax. That's a RepRap derivative. Yeah. So RepRap it stands for self-replicating rapid prototyper. RepRap's just way easier to say than remember. And that's like one of these right here. This is a Mendelmax 2, I think. And the idea is that it can print the majority of the components that it uses are actually made on another 3D printer. So the idea is you buy one of these and then buy a small number of screws and electronics pieces, and then you can actually print another and then another, and then give them out to your friends and they can do the same thing. Yes?
In the future, you'll be able to print things that are
I would assume that wouldn't be an issue. I've never printed anything biological. I know that medical printers make things like that. Like I said, I've heard about printing organs before. But as far as like home hobbyist stuff, I haven't seen anything like that yet.
I've seen like a few things online about them doing it like large scale and printing out like entire tiny homes. How does that
printing out what?
Homes?
Oh, printing out homes. So the cool thing about this technology is you can scale it up or down as far as you want. So like just because this extruder is like 2 inches, it doesn't have to be that big. There's some of them that extrude concrete, and they look like oil drums. And the idea is that you can just print a house by just dropping layers of concrete. Cool idea. I haven't seen one of them. A lot of the companies that have done that have all been like they've been like crowdfunding, or they've been talking about the process, but they haven't really shown any deliverables yet. I don't know how well the concrete would form in that style. That's definitely something that would be easier. I mean, it seems like it would be easier to use conventional like bricks and mortar, I guess. But yeah, the technology can definitely be scaled up to that point, or it can be scaled down even further to print smaller things too.
We were just talking almost like Star Trek.
The replicator.
Yeah.
The replicator is actually the first like 3D printer for like one of the big home use ones is actually called the replicator, and to this day like the popular one is the replicator, and it was actually I think it was like named as like kind of tip of the hat to the replicator in Star Trek.
I was just thinking as like, would you have to like take like if you wanted to print a sandwich, would you like?
Sure, somebody already printed a pizza.
Like that?
Yeah, like you can totally print a pizza.
How do they do that?
So the idea is you have 3 different extruders that are 3 different temperatures. The first one prints the crust. It has the crust like a dough type material coming through it, and it draws the crust out. Then the second extruder has like a tomato paste or sauce, and then it draws that on. And then the third extruder comes up last, and it feeds in like basically shove like a mozzarella stick through it, and it draws that out. And then you have a pizza. Yeah, some people have made pizzas, some people have made bagels, they've experimented with different foods. In general, like a good rule of thumb is, if you can shove it through a hot tube, you can make it on a 3D printer. So people kind of take that and run with it in like all kinds of weird directions.
What about clothing?
I'm sorry?
Clothing.
Clothing? Thread I think would be better off than conventional like loom. I haven't seen anybody. Actually, no, I did see somebody who was making T-shirts using the 3D printer, but like the 3D printing implies like a depth level too. So you have like X, Y, and Z, whereas like a T-shirt really only has, you would have like, you would just have one layer. You wouldn't have that extra like element of depth to it. That would be like a CNC machine would be an example of something that would make something like that. So how does everybody feel? We've learned something? Like,
Yeah.
far as like talking about them goes, I'm a huge like a tactile learner. I love to like touch things and figure stuff out. So hopefully there's a few of you out there too. So everybody's free to come up and check these out. Just if it's moving, maybe don't stick your finger in it. Other than that, come on and let's take a look at this stuff.